Many people love maths on the presumption it's supposed to be logical, predictable, and reliable. But sometimes, maths behaves in ways that feel completely wrong, almost illegal. And yet, every one of these facts is true. Oddly true. Where you can find facts you won't believe are real. Number 1. There are different sizes of infinity. Infinity sounds like the biggest thing imaginable, but in mathematics, infinity isn't just one size. In the late 1800s, the mathematician Georg Cantor showed something shocking. You can list all whole numbers, 1, 2, 3 forever, and that infinity is called countable infinity. But when Cantor looked at decimal numbers, like all the numbers between 0 and 1, he proved something radical, using what's now called Cantor's diagonal argument. No matter how you try to list those decimals, there will always be numbers you miss. That means the infinity of decimal numbers between 0 and 1 is larger than the infinity of whole numbers from 0 to infinity. Mathematicians now talk about entire hierarchies of infinity, with some infinities provably bigger than others, as bizarre as that sounds. Infinity isn't a single concept, it's a structured landscape. Number 2, 0.999 recurring actually equals 1. This one feels illegal immediately. 0.9 recurring is exactly equal to 1. Not approximately, exactly. Let x equal 0.9 recurring. Multiply both sides by 10. Subtract the original x. That leaves 9x equals 9. So x equals 1. Which means 0.999 equals 1. Another way to see it, there is no number between 0.9 recurring and 1. If two numbers have zero distance between them, they are the same number, just written differently. Maths allows multiple representations of the same value. This just happens to be one of the most unsettling ones. Number 3, the Monty Hall problem is real. Imagine 3 doors, 1 prize, 2 empty. You pick one door with a 1 in 3 chance of being right. Before you open your door, the host, who knows where the prize is, opens one of the empty doors. Your original choice remains 1 in 3, but the remaining unopened door now carries the entire remaining 2 in 3 chance. The key point most people miss is switching doors doesn't split the odds, it transfers them. That's why switching doubles your chance of winning. This problem exploded into public debate in the 1990s after being explained by Marilyn Vos-Savon. Despite being mathematically correct, she was publicly ridiculed, including by professional mathematicians who assumed she must be wrong. Years later, simulations and formal proofs confirmed she was right all along. Number 4, proving 1 plus 1 equals 2 took a long time. 1 plus 1 equals 2 feels too obvious to question, but in the early 1900s, mathematicians Bertrand Russell and Alfred North Whitehead tried to rebuild all of mathematics from pure logic. Their work, Principia Mathematica, didn't assume numbers existed. Instead, it built mathematics from logic, set theory, symbolic definitions. Before they could prove 1 plus 1 equals 2, they first had to define what numbers are, what 1 means, what addition means. Only after hundreds of pages of formal logic could they finally prove that 1 plus 1 equals 2 on page 379. Simple truths often sit on incredibly deep foundations. Number 5, a perfect card shuffle is almost impossible. A deck of 52 cards has 52 factorial possible arrangements. That number is about 80 decillion, 80 with 30 zeros after it. That's more arrangements than seconds since the Big Bang, grains of sand on Earth, atoms in the solar system. If you shuffled a deck once every second, it would take longer than the age of the universe to see the same order twice. So the moment you shuffle a deck properly, you're almost certainly holding a sequence of cards that has never existed before and will never exist again. Maths turns something ordinary into something cosmic. Maths doesn't just describe reality. It exposes how unreliable our intuition can be. Things that feel impossible can be perfectly true. Don't forget to follow Oddly True to discover more facts you won't believe are real.